All right, this is Honors Algebra 2 Pre-Calc, and we're doing 4.2 in Algebra 2, which is matrix multiplication. So matrix multiplication is a very different operation than anything else you're going to see. It's a very specific skill that applies only to multiplying matrices. That is one matrix times another matrix. So the textbook example, which I've copied in here, uses football to try and explain matrix multiplication. I personally don't think that this is the best explanation, but I'm going to walk you through it in case it jives with the way your brain works. And then we'll go from there, and I'll walk you through how we actually do this process of matrix multiplication. So basically, matrix multiplication involves both multiplication and addition in this algorithm that you're going to do. So they use football to demonstrate this. So they say a football team scores 5 touchdowns, 4 extra points, and 2 field goals. And respectively, those are worth 6 points, 1 point, and 3 points. So that's the point values of these 3 things in order: touchdowns, field goals, extra points, and field goals. So to figure out how many points are scored, essentially you would do 5 times the 6, which would be the points from touchdowns, 4 times the 1, which would be the points from the extra point, and 2 times the 3, which would be the points from field goals. So what's going to happen is you take this 1 by 3 matrix, right, 1 row, 3 columns, and you multiply it by a 3 by 1 matrix, and you end up with a 1 by 1 matrix, because you end up with 5 plus 6, or 5 times 6 plus 4 times 1 plus 2 times 3, which is 40. So basically, the way matrix multiplication works is that in order to multiply 2 matrices, the outer and inner dimensions are concepts that you have to be familiar with, and the inner dimensions, which here are highlighted in blue, have to be the same. So this is a 1 by 3 times a 3 by 1, and so the inner dimensions are 3, which means they're the same, and the outer dimensions happen to be 1 by 1. The dimensions of your final answer will be whatever the outer dimensions are. So, for instance, if I were to take, let's say that I took a 2 by 2 matrix, and I multiplied it by a 2 by 3 matrix, right? So this is 1, 2, 3, 4, and this is 1, 2, 3, 1, 2, 3, okay? I'm allowed to do this because the inner dimensions match, right? So the inner dimensions match, and then my result, and I don't know why I switched to the opposite colors than they used, but that's fine. So my result is going to be a 2 by 3 matrix because that's the outer dimensions, right? If you had taken these 2 matrices and multiplied in the opposite order, if instead you had taken 6, 1, 3 and multiplied it by 5, 4, 2, right? This is a 3 by 1. This is a 1 by 3. Now you can do this multiplication, right? These are my inner dimensions. But the result is going to be a 3 by 3 matrix. The result would be 1, 2, 3, 1, 2, 3, 1, 2, 3, 3 by 3 matrix, right? This one's result would have been a 2 by 3. Okay? So we're going to practice how to actually do this multiplication a lot in this section. That's basically all we do in this section. That's why this section is called matrix multiplication. So let's go ahead and get to it and talk about how this works. So matrix multiplication is way easier to show you than to explain in words. In a few more slides, I will show you the textbook explanation, but I'm going to say that it is way easier to show you how it works. So we're going to do A times B. So A is a 2 by 3 matrix, and B is a 3 by 2 matrix, okay? So when we do A times B, right, so that's going to look like this. 1, 2, 3, 4, 5, 6 times -1, 0, 7, -2, -8, 9. Okay, so this is 2 by 3 times a 3 by 2. The inner dimensions have to match, so that means that I'm okay to do matrix multiplication, but my resulting matrix is going to end up with the outer dimensions. So what I'm going to do is I'm going to make a work matrix. Okay, so this is my answer, right? So this is entry 1, 1. This is entry 1, 2. This is entry 2, 1. And this is entry 2, 2. Okay, and I'm going to call this my work matrix, just so that I can be clear with how this work's going to look. And then I'm going to make a little answer matrix at the bottom, which for the record is going to look exactly like the answer that I ended up getting on a calculator that you can see in the bottom corner. Okay, so that's going to be my answer matrix. All right, so let's walk through how this works. I'm going to be switching colors a lot because I think it's easier if you can see a color. So in order to do row 1, column 1, I'm going to take row 1 and I'm going to multiply it by column 1 in the following way. The 1 is going to get multiplied. So the first entry in this row is going to get multiplied by the first entry in this column. So I'm going to take the 1 and multiply it by the -1 plus, right? So I just did the 1 and the -1. Then I'm going to take the 2 and multiply it by the 7, right? Which is the next entry in the column. So that's the 2 and times the 7. Plus, and I didn't really give myself enough room for the work matrix here, given that I'm not the best with this pen. Then I'm going to take this 3, and I'm going to multiply it by this -8. Okay, so what's going to happen is I'm going to end up with a -1 plus a 14 minus an 11. It's not an 11. I did 3 times 8 and got 11 minus a 24. Come on, brain. That's it. Sorry. So I get essentially a negative, I get a -1 plus a 14, which is a negative, or which is a 13, minus a 24, so that's going to be a -11. Sorry that I did 3 times 8 and got 11. We've all been there. Anyway, so I take the entries of the first row times the entries of the first column to get first row, first column. Now, if you were doing this in person, what I tend to do, and I can't really show it to you here because I only have one mouse marker, right? Like one. So I trace across with one finger while I trace down with the other finger. So what you can't see me doing on this video is that currently my pointer finger is right here. My other finger would be here, and I would point to the 1 and the -1, and in my brain I'd say 1 times -1 is a -1. I'd move down to the 7, and I'd move my finger over to this 2 and say 2 times 7 is 14. Then I'd move down to the -8 and move my finger over to this 3 and do the 3 times the -8 and get a -24 instead of the -11 that I got when I couldn't add. So you work your way across the row and down the column. And the way you know which row and which column to use is based on what your entry is, right? This entry is in the first row and the first column of my answer. So I use the first row of the first matrix and the first column. Okay, so now let's do the next one. All right, so I'm going to keep my green for this row because notice I'm still using this row, but I'm going to use blue for this column. So it's going to be the 1 times the 0, right? So this spot, and again, I didn't really give myself enough room, sorry. It's going to be 1 times the 0, right? Because that's the 1 times the 0, plus the 2 times the -2. So the 2 times the -2, that's this guy times this guy, plus the 3 times the 9, right? And that's going to end up being 0 minus 4 plus 27, which is definitely a 23, and that's absolutely what we get here when we check on the calculator, right? So now at this point, I'm now done with row 1, because notice that was all row 1, right? Now what I need to do is I need to use row 2, which is going to be these guys. So for row 2, I'm going to use row 2, and then I'm going to use whichever column I'm looking at in my answer, right? So like this is column 1, so row 2, column 1. So to get this one, right, to get this entry right here, I'm going to take the 4 times the first entry in column 1, so 4 times the -1, plus the 5 times the 7, plus the 6 times the -8. And then if I clean that up, I'm going to end up with a -9 plus a 35 minus a 48, which is definitely a a positive 26 rather. Come on, brain. Positive 26 and a negative, oh, that's a 4. I can't copy my own work. That makes way more sense. Positive 31 and a negative 48, which is a negative 17. Sorry, I thought that was a 9 when I wrote it here, but it's a 4. Come on, brain. Okay, so anyway, negative 17. And then finally, to get this last spot, I'm going to use the last row and the last column. So it's going to be the 4 times the 0, right, plus the 5 times the -2, plus the 6 times the 9. right? And that's going to be a 0 minus a 10 plus a 54, which is definitely a 44. And there's the same answer I got on the calculator, although if I had better handwriting, this would be a lot easier. Anyway, that's the way matrix multiplication works. So you work your way across a row, down a column, right? But it's the reason that you need your inner dimensions to match, because essentially, if these 3 columns have to line up with these 3 rows, or else there's not enough entries to make this work. Okay, let's go ahead and try. BA. So we're doing this together, and we're going to walk through. Now, BA is going to be a big matrix. It's going to be 3 by 3. So if I put BA next to each other, let's go ahead and set this up. So if I put BA, so I have -1, 0, and I'll give myself a little bit more room this time to make this answer. All right, -1, 0, 7, -2, -8, 9. Sorry, -8. And then this guy was a 1, 2, 3, 4, 5, 6, which is at least not super hard to remember. Okay, so this is a 3 by 2, and this is a 2 by 3. So these inner dimensions mean that I can multiply, and the outer dimensions give me my answer. So I'm going to end up with a 3 by 3 matrix. So what that's going to mean is I have 1, 2, 3. 1, 2, 3. 1, 2, 3, right? And that's not super impressive, but that's the idea. Okay, and then I'm going to have my answer that I'll probably end up writing down here, but honestly, it's going to be the same answer that we get on the calculator. So my answer matrix is going to look like this, where I just have blank spaces so that I don't accidentally forget something. Okay, so let's go ahead and work through this. So for this entry, 1, 1, right, I'm going to use row 1 and column 1. I work my way across the row and down the column. So -1 times 1 plus 0 times 4, right? So that is going to be a -1 plus a 0, which is totally a -1, which is absolutely what we get here. For the next spot, I'm still going to use row 1, but I'm now going to use column 2, right? And I work my way across and down. So -1 times the 2, so -1 times the 2 plus a 0 times the 5. Well, that's going to be a -2 plus 0, which is totally a -2, and that's exactly what we have here, right? For the last spot, again, row 1, now I use column 3. So -1 times 3 is going to be a -3, and if you want, you could just kind of do that, and 0 times 6 is going to be a 0, so sure enough, I get a -3, and that's exactly what's here. If you wanted to write it out as all of them, you certainly can. So when I ask you to show work at something like this on a test, I need to show some level of work. It doesn't have to be every single step, but the idea is that you're not just plugging it into a calculator. Okay, so now let's keep working our way across. So now we're done with row 1, right? So row 1 is officially over, right? Done with row 1. Sorry, my bad. Didn't mean to do that. There we go. That's what we wanted. Okay, sorry. All right, so we're now going to use row 2, column 1, right? And I go across the row from left to right and down the column. So 7 times 1 plus -2 times 4. Well, that's a 7 and a -8, so that's a -1, which is exactly what I get here, right? Next, I'm going to have the 7 and -2, and the 2 and the 5. So 7 times the 2 plus the -2 times the 5. Well, that's a 14 and a -10, so that's a 4, and you'll see that's exactly what I get here, right? Next, I'm going to have the 7 and the -2 with the 3 and the 6, right? So 7 times the 3 plus the -2 times the 6. I kind of ran out of room. So that's a 21 and a -12, which should be a 9, and sure enough, that's what's here, right? Last row. So now I'm done with row 2. Row 3 is the -8 and the 9. So I'm going to do row 3, column 1. That's going to be a -8 times a 1 plus a 4 times a 9, or a 9 times a 4. It doesn't really matter. So that's a -8 and a 36, which is definitely a 28. And then sure enough, over here, there's a 28. I take that row 3 by column 2. That's going to be a -8 times the 2 plus a 9 times the 5. Well, that's a negative 16 and a positive 45. So that's a 29. And sure enough, there it is, right? And then the very last one, which I guess we've already been doing a lot of red, so let's just go for red again, is the negative 8 and the 9 times the 3 and the 6. This is going to be a negative 8 times the 3 plus the 9 times the 6. It's a negative 24 plus a 54, so that's a 30, and sure enough, that's my answer. So that's how matrix multiplication works. Now, you're probably thinking, boy, it would be nice if my calculator did this. And your calculator totally does it, which is how I got these answers, right? So if I go to second inverse and I go over to edit, I can go ahead and make my matrix A into the, what is it? It's a 2 by 3. 1, 2, 3, 4, 5, 6. Boy, that's a nice friendly matrix to type into your calculator. And then I quit out, right? Second quit. And then I go back to matrix, go over to edit, go down to B. And this is a 3 by 2. And it's negative 1, 0, 7, negative 2, negative 8. That's not an 8. Come on, buddy. All right, and 9. And then double check that it's right. Looks right to me, and then I quit out, and then sure enough, I can type in second matrix. I want B, second matrix A, and there you go, right? So there's nothing wrong with typing in your calculator, but you should know how the process works in general. So on the next slide, we're going to go to the actual book definition of how it works, but the only way you get good at this is by practicing it. It's not the kind of thing where a definition helps. So we have matrix A is m by n, and a matrix B is n by r. Then the product AB has dimensions m by r. And then they explain that in order to find an entry in row I, column J of AB, you take the sum of the products of the corresponding entries in row I of A and column B of J, which is what we just said, but is very complicated. So here we have an A and a B. We're just going to go ahead and look through the difference of finding both of them. So let's go ahead and real quickly find AB. Right, so AB 2, negative 1, 3, 0, 5, 1. B is going to be 1, 0, 2, negative 1. Okay, so this is a 2 by 3, and this is a 2 by 2. Because of that, these are not the same. This is not possible. Okay, this is a dimension mismatch because you can't multiply. So dimension mismatch. Basically, the inner dimensions don't match, right? So that's not possible. But we can find BA, right? So BA is going to be 1, 0, 2, negative 1, which is a 2 by 2, times 2, 0, 2, negative 1. What's wrong with my brain? Positive 3, 0, 5, 1, right? So I'm going to fix that negative 1 so that I don't get completely confused. All right, cool. So negative 1. Okay, so now I can multiply a 2 by 2 times a 2 by 3, and the result, see their inner dimensions match, the result will be a 2 by 3, right? So I know ahead of time that my answer should have 2 rows and 3 columns. Okay, so, and I'm going to go ahead and put my final answer up here because we're a little low on space. Cool. So if I take row 1 by column 1, I get 1 times 2 plus 0 times 0. So that's a 2 plus a 0, which is a 2. If I take row 1, column 2, I get 1 times negative 1, which is negative 1, plus a 5 times a 0, which is a 0, so I get a negative 1. If I take row 1, column 3, I get 1 times 3, which is 3, plus 0 times 1, which is 0, so I get a 3. If on the bottom I take row 2 times column 1, I get 2 times 2, which is 4, plus 0 times negative 1, which is 0, so I get a 4. If I take row 2 times column 2, I get 2 times negative 1, which is a negative 2, plus negative 1 times 5, which is a negative 5, so that's a negative 7. And if I take the last one, bottom row times the last column is 2 times 3, which is 6, plus a 1 times a negative 1, which is a negative 1, so I get a 5, and there's my final answer. All right, cool. So Let's go ahead and walk through example 1 after all that, which is, basically to say that we've done an awful lot of examples already, but we're going to call this one example 1. I did warn you we'd do a lot of examples of this. So let's go ahead and find HG first. So 2, -3, 1, 5, 6, 0, 4, 7. They are both 2 by 2s. So not only is it okay, but the answer will also be 2 by 2. So I'm going to go ahead and make a 2 by 2 work matrix and a 2 by 2 answer matrix. And you don't have to do this, but if you're doing work by hand, it's really helpful to have a work matrix. All right, so let's start with row 1, column 1. 2 times 6 gives me a 12, and I'm going to add that to a -3 times a 4, which is a -12. So that's a 0. 2, -3, and the 0, 7 is going to be a 2 times 0, which is 0, plus a -21, which is just going to be a -21. Now I'm on to my second row, first column. So 1 times 6 is going to give me a 6, and 5 times 4 is going to give me a 20. So I'm going to get a 26. And then last but not least, second row, second column, 1 times 0 gives me a 0, 5 times 7 gives me a 35, and I get a 35. So that's H times G. Now let's do G times H. So same thing, opposite order, and what we're going to find is it is not commutative. But we already kind of knew that because we've seen that when I multiplied the opposite order for all of them, it didn't go very well. They were not the same answer. So my inner dimensions are the same. My outer dimensions are the kind of matrix I'm going to get. So I'm going to get another 2 by 2. All right, so let's start with row 1, column 1. 6 times 2 is 12. 0 times 1 is 0, so I get 12 plus 0, which is 12. 6 and 0 times the -3, 5 is going to be a -18 plus a 0, which is a -18. 4 and 7 times the 2 and 1 is going to give me an 8 plus a 7, which is a 15. And last but not least, 4 and 7 times the -3 and 5 is going to give me a -12 plus a 35, which should be a 23. And that's my answer. Cool. So moving forward, let's go ahead and do our P1. So for P1, you're going to do the same thing, but they are not exactly the same dimensions. So go ahead and give this a try. You can pause me if you want. So RW, notice that R is a 3 by 2 and W is a 2 by 2, right? So RW is going to be 2, -3, 0, 5, -2, 0, which is again a 3 by 2 times 5, 0, 4, and 7, which is a 2 by 2. The inner dimensions do match, so the outer dimensions are my answer. So my answer is going to be a 3 by 2, right? So a 3 by 2 looks like this, right? 2 columns, 3 rows. And I'm going to go ahead and put my answer right here. All right, we'll deal with WR in a sec. All right, so row 1, column 1. 2 times 5 is 10. The -3 times the 4 is a -12, so that's a -2. The 2 and -3 times the 0 and the 7. 2 times 0 is 0. -3 times 7 is a -21, so I'm going to get a -21. Okay, on to row 2, 0 and 5 times the 5 and the 4. Well, that's 0 times 5, which is 0, and 5 times 4, which is 20, so 0 plus 20 is 20. Row 2, column 2, 0 times 0 is 0, 5 times 7 is 35, 0 plus 35 should give me a 35. Row 3, column 1, -2 times 5 is a -10, 0 times 4 is a 0, so I get a -10. And last but not least, the -2 comma 0 times the 0 and the 7. So 0 times the -2 is a 0, 0 times the 7 is also a 0, and so there's my final answer. Now for WR, WR is going to be a 2 by 2 times a 3 by 2. I don't have to write them out to notice that that's not a thing. That's not possible. So not possible, dimension mismatch. And that's it. That's all you have to do. You have to be like, hey, this is a thing. It doesn't work. Okay? Cool. All right. Moving forward. All right, that's going to be the end of this video.